the two circuits are equivalent of each other, meaning the circuit on the left is equivalent to the circuit right here. Find the voltage source and the equivalent resistance. So we have to find the voltage source and we have to find out the resistance. Now, one of the best approach to a problem like this is to apply a superposition theorem. Now, if you are very new to superposition theorem, is what we do with superposition theorem. If you notice here, we got two kind of sources. One is the current source right here, and then we also have a voltage source over here, DC. We keep one source, do the analysis, and then restore the other source, and then do the analysis, right? So we're going to start off by removing the current source here, right? Removing current source here. And when we remove current source, we basically replace it with a open circuit, with an open circuit. Now, you have a DC source here. The current is going to flow in this direction because the current always travels from a positive terminal to the negative terminal, which means the polarity over here will be plus and minus. And because this is just simply a series circuit, there's nothing going over here. There's nothing going over here because the current has no route. This is open circuit, so 0 amps over here. And then again, open terminals over here. There's no route for the current to flow. So the current will just simply take this route. And because this is just one component 4 ohm, so the voltage across this 4 ohm is just simply going to be the 10 volts. Remember, this open circuit voltage, which you could refer it to VAB if you like, which this will eventually be the source voltage here, correct? So we know from here to here it's 10 volts. Now I am going to restore my current source and remove my voltage source. Now when we remove the voltage source, it is replaced by a short circuit in your circuits. It's a short circuit now, right? Now notice over here you have 3 amps coming out of this source. The current will take this route. This is an open terminal, so they can't go over here. So then current will take this route. Once the current gets over here, it has two options. You know, it could go here or it could go here. Well, the current will take this route because this is a short circuit. Current will not take this route because there's a resistance. Current always prefer the path of the least resistance. So it will just simply go here and then returns back to the circuit. And what I could do over here in order to find out the voltage over here, remember, since current is flowing in this direction, you'll have positive here and negative here, correct? So the voltage is simply going to be a product of current and resistance. V equals to IR. 4 times 3 is 12 volts. 12 volts. Okay, now we have independently figured out the impact of these sources. We're going to have to add the two sources. Remember, we have a polarity here, plus, minus, plus, minus. So we have plus, minus over here, correct? Now, if you notice the polarity here across this resistor, it's opposite to that of this right here. Similarly, if you look at the polarity across this resistor, it's opposite to that of the open terminals over here. Hence, when we add the two voltages, 10 volt and 12 volts, which is going to be 22 volts, we're going to have a negative sign here. We're going to have negative sign here. Why? Because there's a polarity mismatch, very similar to the previous problem. Now we're going to have to find out the resistance. We can also refer this to a Thevenin's resistance. When you're trying to find out the Thevenin resistance, you have to remove all the sources. So the current sources are replaced by an open circuit, and a voltage source is replaced by a short circuit, just like we did when we did the superposition theorem. Now we look at it from a perspective of these open terminals looking towards the circuit. So the current is going to simply take this route right here because this is a short circuit, right? Just go this way. It will not take this route of the resistance. And then once it goes over here, it then takes this route and then returns back to the circuit. So this is how it completes its route, completes its orbit, and hence there's only 4 ohm which is acting as a resistor. Hence this equivalent resistance of this network is simply just 4 ohms, simply just 4 ohms.